everybody, this is Dr. Chilton. I'm going to be your instructor this semester for Physics 152. Today we're going to be talking about Faraday's ice pail experiment. One of the main devices that we're going to be using in this experiment is something called an electroscope. And an electroscope is any device which indicates the presence of an unbalanced charge. Back in Faraday's day, they would have made an electroscope this way. There would be a glass jar, a copper rod that went through the top, two gold leaves that hung from the bottom of the copper rod. Then, if you had a plastic rod, which you had rubbed with fur, it would get a negative charge. When that touches the end of the electroscope, the charge is transferred to the gold leaves and they repel each other. And therefore, you would know that there was a charge present. Now, this, on the other hand, this does not tell you whether the charge is positive or negative. If this was a glass rod that you had rubbed with silk, it would have a positive charge, then the leaves would get a positive charge, and they would still repel one another. So you can tell that there's a charge, but you cannot tell whether it's positive or negative. These days, electroscopes look more like this guy right here. What I'm going to do is I'm going to rub this piece of PVC pipe with fur. It's going to obtain a negative charge, and then I'm going to touch it to the top of the electroscope. Okay, and so the electroscope rotates instead of separates. Now, let me get rid of that charge. Okay. Helps sometimes to touch this to something metal to get rid of the charge. Okay. Now we're going to try it with a glass rod and a piece of silk. Now, I've found that you don't usually get quite as much charge this way as you do with the plastic and fur, but I think you'll be able to see that it still does the same thing. But to a lesser degree.
Go.
This object here is the electroscope that we're going to use for this experiment, and it has the advantage of not only is it more sensitive than the other electroscopes that we looked at, but it also has the ability to tell us whether the charge is positive or negative. Now let me show you a couple of things on this before we start. First of all, this is battery powered. Now, if you get one of these and it's not working, you can change the batteries by taking those screws out. You should probably just ask your instructor to do that if that's the case. So now it's on. Okay, here's the power switch here. And this is the range switch, and you have choices of 3, 10, 30, and 100 volts. Okay, and then there's a 0 switch that sets the scale back to 0. Okay? You want to hook to that the input signal cable. That's over here. And you turn that all the way. Now, one of these has a red mark on it. You need to know which one's got the red mark. Okay? Now, I want to show you that this can indicate the presence of a charge. Okay. Let's start off on a 10-volt scale, see what we get. Okay, well that's not quite enough. Let's change it to 100 volts. And so I get a voltage of negative 20 volts, which indicates that the charge is negative. Okay, the glass rod is positively charged. So if I bring that over there, I should get a positive charge. It's not going to be quite as impressive, but it should still be positive. Okay, so this device is able to tell us not only whether there's a charge or not, but whether that charge is positive or negative. You can also see that if you want, you can hook this up to the terminals of a battery. This is a 9-volt battery. Oops, too high a scale. So on a 10-volt scale, about 7.4 volts. If I switch this, then I should get about negative 7 volts. Okay, so one thing I should point out to you about this is telling me volts, not coulombs, but as it turns out, the voltage is proportional to the charge, and as we will see later on, that's something we're going to talk about later in the semester when we talk about capacitance. This object is the Faraday's ice pail. You might say, well, heck, you can't put much ice in that. Faraday's ice pail did not obviously look like this. It was basically just a bucket. You might notice that there's also an inside and an outside screen. What the outside does is it shields the inside from the effects of charges external to it. Okay, now when you hook this thing to the electroscope, this end with the red that's marked in red goes to the inside, and the other one goes to the outside cage. If I rub the plastic with a fur and place it inside the cage, you'll see that I get a voltage that's off the scale even for the 100-volt scale. But if I put the same thing outside, it doesn't do anything. Okay, the reason for that is that the outside screen is shielding the inside from the effects of external charges. With each Faraday's ice pail apparatus, you get 3 wands. These 2 wands are charge makers, and this is a charge sampler. It's a piece of aluminum. Okay? The ones that make the charge, this is hard plastic, and this is something sort of like felt. So it's similar to rubbing the plastic rod with the fur. Now, let me change this scale. I want it in the 30-volt range. I'm going to rub the 2 charge makers together. Okay, Now that side is like the plastic pipe. It should have a negative charge, and so I should get a negative voltage. Okay, and I get a voltage of around negative 30 volts. And if I stick the one with the felt in there, it has a positive charge that's pretty much the same thing. Now, the third component we're going to add to this experiment is an electrostatic voltage source and a conducting sphere. Now, the conducting sphere has to be connected to one of these supplies over here. Okay, you've got 30 volts common, that means ground, and then 1,000 volts, 2,000 volts, and 3,000 volts, which sounds kind of scary, but it's really not, because this 3,000 volts is connected in series with a very large resistor, and so even though the voltage is high, the current that you would get if you accidentally touch this thing is very small. Not saying you should try to do that, but it's not going to hurt you. Okay, so the sphere has to be connected right there to the red wire, and I'm going to connect the red wire to the 3,000 volt outlet. Black is common, and that has to be connected to the electroscope right here where it says ground. Okay, now the power, this is not battery operated. Okay, and so you turn it on and off back here when the light's on, that's green. Okay, so what's happening now is this is charging the sphere. Okay, and what we want to do is to show that we can sample the charge. Here's the sampler, or often called a proving plane. Touch it to the sphere, and then we can insert it in the electroscope, which we have recently discovered is a way of measuring charge. So if I touch it at that point and then insert it in there, I get a voltage of about 16 volts. Okay. Now let me ground that, and I'm going to touch it in a different place, and I should get the same voltage. Okay. This indicates that the charge is uniformly distributed on the surface of the sphere. Now, if I then plug the voltage source off, okay, and then touch that to a second sphere, touch and separate, then I should find that they both have the same voltage. Okay, so that's about 6 volts. And now let me ground that. And if I touch this one, I get 6 volts there. In other words, half of the charge that was on this sphere has gone to that sphere. There are going to be 3 parts to this lab. The first part is just looking at the electroscope, seeing what happens when you bring a charged object near to the output cable. The second part, you're going to connect the electroscope to the ice pail and insert the charges in there, and one of the times you do that, you're going to touch the side, and you're going to be recording voltages when you stick the different objects in there, and recording what happens when you touch the side. Then the final part is with the spheres. You hook that up, you're going to sample charges from various places on the sphere, record those voltages, and then finally you're going to turn off the voltage source, let the two spheres touch, and you're going to verify the fact that the charge on the two spheres has pretty much been split into two parts. Now, if you have any trouble or you have any questions, there will be a physics faculty member available when you're doing the lab, and you can ask questions of that person. So this is Dr. Chilton. I'm signing off now. Good luck to you on this lab, and see you again soon.